Hi there, my name is Mrs. Dinkelman and I teach calculus here at Boise High. And Mr. Ruffing just asked me to talk about how we might use graphs in math and why we would learn them in math class. So I thought I would talk about the data I've been collecting for COVID and just show you what the graph looks like and when they talk about flattening the curve, what they're talking about. So this is a particular graph called the logistic equation. You might have potentially talked in your biology class about something called a carrying capacity, and that's really just in a population. For instance, if we have some growth going on, that things can't grow without bound, that at some point something has to level off, and that leveling off is the carrying capacity. We'll talk about what it means here with COVID data. You might have heard of some curves or some things growing exponentially. So this is sort of like an exponential function for a while, and then it kind of turns around, just so you know. So we'll kind of look at the pieces of the graph, and I'll talk about, again, what it means here. So first of all, if you look at my picture, if I zoom in a little bit here, the dark green is really the data that I've collected. And then what we tend to do in math is try to find a function, whether that's a line. You might have heard of line of best fit before. So sometimes things grow in a linear way, and so we would try to put a line there. Sometimes things grow exponentially, so we would want a exponential curve there. And then this one, I'm trying to do the logistic because there's something specific I'm trying to find out about it. Okay, so there is some data, excuse me, that I haven't put in here yet. So I'll put that in so you can see it. What I'm the most interested in, there's really two things on this particular set of data. One is this carrying capacity. So notice how this kind of flattens out, and I want to know when that, or it's really not when, it's really how many people will be infected by COVID. That's what that flattening out is going to tell me on this particular curve. So I can kind of see that on the graph. And then the other thing is, they've been talking a lot, I haven't heard it lately, but especially at the beginning when we were quarantined, they talked about flattening the curve. And so you can barely see that curve that we're trying to flatten here, but I'm interested in that curve. And I just want to tell you that that curve that they've been talking about, like on the news, etc., is actually, it's called a differential equation. It's a calculus curve, and it talks about the rate of growth. So we're trying to keep the rate of growth down. So I like to look at those. So right now, I'm going to sort of try to estimate what the top of that curve is. So the top of that curve occurs at basically day 293, and we'll talk about what day we're on right now once I get this data on. So when I had finished this data, look, I ended up on 303. So what I was basically saying at that time was that 10 days ago, we had our peak. And then I actually have something programmed in here to tell me what the carrying capacity is. And it's this A value. So it's 245,000. So if I go back to the graph and look at this curve, you can see, and maybe you saw earlier, it looks like it's about 250,000. So again, based on this data, my prediction is that 250,000 people in Idaho will be infected by COVID before we kind of see the end of this. All right, let's see how that changes as I put some more data in. So I have some written down here that I will insert, and then we'll just take a peek at what it says after that. I just kind of try to collect it about once per week and just see what's happening with it. So you can kind of see the curve moving as I put the data in. And that's, again, mathematicians tend to use graphs and equations to predict future behavior and figure out what's going to happen in the future. Unfortunately, data is not always really nice. We want it to behave nicely as mathematicians, but unfortunately, it doesn't always. So we have to do what's called a model and do something that we think is pretty close to what it looks like it's doing. And I guarantee this is what, what they're doing, like the scientists are doing. And they might have different models to use, and they also have computer programs that help make it a little bit faster for them as well. And then they can add more variables in, because what happens now that people are getting vaccinated, or, if the virus starts to mutate, and what that does to all the data. Okay, so I put in through day 310, and again, that's kind of changed a little bit. If you noticed, my carrying capacity, so that's that number that I'm using to predict how many people in Idaho will be infected. This is just Idaho data. And also, by the way, I'm only collecting the confirmed cases, not the confirmed and probable, just so you know. So this is actually kind of good news, because that A value that we had before was at 245, and now it's at 223, which means our carrying capacity went down, which is great, because what that really means is we're leveling off a little sooner than the model was originally predicting, which is really good news, honestly. Okay, let's look at that curve we're trying to flatten. And again, the scaling is kind of weird because we're looking at both, but if we can kind of find the top of it, which Desmos will do for me, it says that day 284 was our peak. So that's when the rate of spread was the fastest, and we're on day 310 according to my data. So that was about a month ago, a little bit less than a month ago, is when our rate was the fastest according to this model. And maybe we kind of think about the news back then about how hospitals were having a hard time with all the patients, and we were looking at how many people per day were getting infected. That kind of makes sense to my brain, at least. So this is just one example of where we might want to look at a graph in math. And I know this curve is maybe a little bit more difficult than doing a line, but we have to learn how to do lines and parabolas and exponentials and all of that before we can get to curves that look like this. But clearly in the news, we hear about them, and it's nice to know that we can actually use that data as well. So this is just one way that we might use a graph in math.